record to cloud. All right. Well, good afternoon, everyone. Hope everyone's day is going well. I'll be giving a kind of high-level overview of Azure Data Factory. So we'll go ahead and jump in here. So we'll start off. What is Azure Data Factory? Azure Data Factory is kind of lays out here. It's cloud-based ETL data integration service. Allows you to create data-driven workflows for orchestrating data movement, transforming data at scale. Basically, it's ETL, ELT tool similar to SSIS in a lot of ways, but it has a lot more functionality, I would say, than SSIS. It supports CI/CD through Azure DevOps and GitHub, and it uses JSON to kind of define different processes and components. It works with structured, unstructured, and on-premises data. And, of course, with structured, you're thinking databases like SQL and whatnot. Unstructured, you might be thinking about a data lake. And then, of course, on-prem, and, work with anything you have tied down to some on-prem machine. It's able to pull data from a large number of sources. We'll see in another slide later that it can connect up to a ton of different things out of the box, which is very convenient. And it's also easily scalable. So that's kind of the nice part as compared to things like SSIS. Go ahead. Odd slide, Beetlejuice, weird. I don't know where that came from. So example one here is an example of Azure Data Factory and kind of modern data warehouse. So we can see, the data factory lives kind of here and kind of the first step in this layout. This is just an example of how you might lay out a data warehouse. Of course, you'd have to do it this way, but this is just kind of show where Azure Data Factory might fit into different positions. So you can see in here, it's taking things from like files and logs, taking things from the database, taking data from, some applications. And it's basically combining all of that, transforming it and storing it over here in a data lake. So, unstructured data. And then later you can see that data lake is going to be processed by some other things. So that's one example of how it might fit into a warehouse. Microsoft, of course, offers their helpful visual guide of what Azure Data Factory is. I believe this is a little overwhelming. Has quite a bit. So, you may find this helpful. I did not. I thought this was kind of a little confusing how they laid it out here, but wanted to include it just so that, everyone's aware that Microsoft's visualization of it is here. Here's another example of Azure Data Factory, kind of an automated enterprise business intelligence solution. So again, you could see it's kind of connecting to a number of different data sources there, taking in the data, storing it, and then, analyzing it using Azure Synapse within the data factory, and then passing it out to an analysis service to be used by Power BI. So again, just another example of how it might, live in an ecosystem. So in Azure Data Factory, some important high-level concepts or key components are the pipelines. So the pipelines are effectively a unit of work within Azure Data Factory. So, it might be moving some of the data from one spot to another. It might be, reaching out to get log files and process them, store them somewhere. Again, just simplified, it's a unit of work. There's activities. So activities within the pipeline, there's step in the pipeline. So, you might be copying data in one step, and another step, you may be using a data flow that might transform that data. Data sets. So data sets are a reference to data structures or store, kind of like, so it could be blob storage, could be a REST API even, could be SQL database, different stores or places you may structure data or store structured data, sorry. Link services. So So link services are just basically connection strings when they're simplified. It's anything that you might link out to in Azure as a service. I mean, it goes further than Azure, of course, but it's different things you might be connecting to or utilizing in your pipelines. Data flows are basically little chunks of reusable transformation logic. So if you need to, let's say apply an aggregate or, flatten a JSON data, that has an array in it. That's where data flow might come into play. And then integration runtimes. Integration runtimes are, as it says there, the compute environment, basically the environment that the computations and the processes you run on. That's where the scaling will come into play. One thing that gets brought up a lot when Azure Data Factory is discussed is comparing it to SSIS, kind of its predecessor. And so a number of the things I've seen when you compare these two is kind of broken down here. One is, again, if it's on-premise or if it's serverless. So if you're kind of tied down to an on-premise environment, like a VM or IaaS, you may lean more towards SSIS just because it kind of works better in those environments to a large extent. However, if you're working a lot in Azure or you have a tenant and you have a lot of Azure resources, you're probably going to lean Azure Data Factory because it's going to be able to connect and integrate and utilize a lot of these a lot better, a lot more easily than SSIS. ADF is not a replacement for SSIS. It may be seen that way, but it really is more of a supplement. In fact, you can use SSIS packages within Azure Data Factory, so it can be seen more as a supplement to SSIS. So if you have existing SSIS processes, you could use Azure Data Factory to process those and to do other things for you in a more serverless fashion. Has a drag and drop GUI similar to SSIS, so both of them kind of offer that code-free, low-code interface. Performance is one where, it differs. SSIS performs better, and I kind of have a source here from what I've read on some smaller and larger operations, whereas Azure Data Factory is really going to be a powerhouse when it comes to these larger transformations and data orchestrations. Flexibility. SSIS, again, as I kind of alluded to earlier, it's kind of tied down to mostly being on a server. Now, again, you could use it in Azure Data Factory, but that's where Azure Data Factory is really going to offer you a lot more flexibility with regards to what you can connect up to, how you can process the data, and again, how you can scale it. And then the pricing models also differ. So SSIS being tied to a server, you're going to have more of a flat cost schedule. It's going to be, pretty predictable and all of that. With Azure Data Factory, you pay as you go, and you pay for what you use. So it's a little bit more of a dynamic pay schedule. But again, that means it could be cheaper, could be more expensive. It just depends on your use cases. So in Azure Data Factory, there are a number of triggers, which are very handy. So you can manually, of course, trigger it from the UI. There's scheduled options, so you can schedule it, weekly, monthly, daily. There's a number of different ways. There's a REST API that you can invoke it from. So if you wanted something to programmatically invoke this, uses some sort of REST API or pings an API, you could do that. Works with Azure PowerShell. So if you had some script that you needed to, kick this off with, you could do it that way. There's also a .NET SDK. So again, if you didn't even want to mess with the REST API, but you still wanted to be able to use this in your .NET code, you could. And then there's also event-based triggers. And so these kind of, there's two kind of flavors, and one's storage event triggers. So that would be when a file gets put in this blob container, kick off this job. And then another one would be the custom event triggers, which tie into the Azure event grid. So I'm not going to go too in depth in that, but Azure event grid, suffice to say, when you do certain things in Azure, they'll kick off into the Azure event grid, so you can have it trigger the Azure Data Factory as well if you want. As I kind of mentioned, Azure Data Factory connects up to a lot of different data sources. Can't really list them all off here, but there are, suffice to say, a whole pile of them. So of course, works with Azure data sources like blob storage, data lake, Synapse Analytics. I mean, sky's the limit. Basically, what Azure has in it, you can connect to. Works with 29 different databases, including for SQL, Google BigQuery, some of the ones I've listed here, Oracle. Also worked with NoSQL databases like MongoDB, DB, Cassandra, Couchbase. Works with a number of different file systems, so including Amazon S3, Google Cloud, Oracle Cloud. It also works with some generic protocols, so HTTP, OData, ODBC, and REST. Well, that's kind of nifty because, again, that means, sky's kind of the limit there. And then it also works with a number of different services that are used in kind of enterprise solutions. So like Google AdWords, for instance, or, Amazon Marketplace, Salesforce, ServiceNow, it can tie into those too. It's kind of odd. Beetlejuice, huh? Weird. Azure Data Factory supports a fair amount of file formats. So you got Avro, binary, common data model, delimited text, just a number of them that you probably have seen before, probably are familiar with. JSON, Excel, of course, is on here. XML, again, some pretty standard formats, but again, there's some flexibility there. So with regards to source control and CI/CD, Azure Data Factory is set up to integrate very well, of course, as you might guess, with Azure DevOps. And it specifically ties up to Azure DevOps Git and GitHub. They sadly do not support Bitbucket right now. I don't know if they're going to do that in time or not. I couldn't figure that one out. But so suffice to say, it will work with DevOps Git and GitHub out of the box. It's recommended, of course, if you go this route, that you set up an ADF instance for each environment. That way you can, develop in one environment, test it in another, maybe have a staging that you could, last minute or UAT kind of environment, and then a production environment. And likewise with these, you'd want, analogous key vault storage accounts, etc. Just a good CI/CD model. Development environment is tied directly to the CI/CD tool. So you basically have this when you develop and you publish changes, you'd have that go ahead and put those, basically publish some artifacts out for deployment to your other environments. And again, ties really well with Azure DevOps. Again, as I kind of mentioned earlier, this uses ARM templates. So again, it's JSON-based templates, similar to a lot of the Azure resources, to store the configuration and the pieces of the Azure Data Factory. So Microsoft offers out of the box too, a very nice pre and post deployment script. It's highly recommended. It handles things like stopping, starting, cleanup, remove resources. I put a link here in the slide in case anyone needs it. Again, it's in their documentation, and it's very, very highly recommended from what I've read. Takes in a couple simple arguments, flags. So, template location, resource group name, data factory name, whether it's pre-deployment, post-deployment, it's just a bool. And then whether it's going to delete the deployment at the end of it. So again, very, very handy, and it goes to show Microsoft's really trying to help out with making this a simplified process in things like Azure DevOps. Scaling ADF, again, as I had mentioned, it's pretty straightforward. You of course have your two options there, scale out and scale up. Scaling out consists of adding a new node to the integration runtime. So you can have multiple processors within your integration runtime. Again, you use this when your CPU and memory are capping out, when you're noticing the resources are maxed out, might need to add another node. Scaling up, on the other hand, you consider doing when your CPU and memory aren't being fully utilized, of course. So scaling up involves increasing your data integration unit, or DIUs. This can be done on individual activities and on the integration runtime. And the other way to scale up, of course, is to increase the number of cores that you can be processing on. Huh, Beetlejuice. Uh-oh, that's 3 times. All right, so it's showtime. So now we'll go ahead and break out into the demo portion of the presentation. So I have in the Simpat Azure tenant a kind of proof of concept. This was originally for a different proof of concept, but I've just utilized this data factory to kind of give some examples. So one thing I'd like to start out with is I have one pipeline here called demo movies. So this pipeline, it's going to process a CSV file that just has some movie data in it. So just to give kind of an example of what that might look like, I'll open up this file here. So we got a CSV file here, movie CSV. It's got some movies in it, title, genre, year, some ratings from 1 through 10, and then a Rotten Tomatoes score. And so this CSV file I have uploaded to a container in Azure Blob Storage here. So there's this storage account here. I got this container of movies, and in here you can see the movie CSV file I just mentioned. So if we hop back over here, we can see in the pipeline we've got 2 data flow activities. So one of them is called average movie rating. So if I go ahead and double click that, we'll see the data flow and kind of how it's laid out. So the data flow, again, is kind of a reusable set of transformation logic. And, like in this case, it's aggregating the average ratings. So it starts out with a data source. So we're going to import from, of course, this movie source. If we take a look at that movie source, we can see it's, as I had mentioned, it's a connected link service to Blob Storage. Gives it a file path and a name of what the file is. It'll automatically pick up the schema based on that. So you can see here, you can see already the schema based on that CSV. And so it's going to go ahead and show us, it's going to project out these columns. So it'll be available for us to transform, do things with. I have a filter here. So this is filtering by years and genre. So we can see it's filtering movies between 1910 and 2000 that are in the comedy fantasy genre. And then we can see I've got aggregate here. Aggregate's simply grouping by year, and then giving us, again, you can plug in kind of some expressions. And so in this case, I got average of the rating. The expression builder is very nice. Kind of will give you some values you can use directly from your data source. So again, you can see these columns that came from the CSV, like the movie, title, genres. And then of course, there are some standard functions in here, so some date calculations ones, and, bitwise ones, again, pile of them. And so again, you could apply those to a number of the different steps, parameters, and components of the data factory. In general, all the activities have them. So we can see, again, this is going to be doing the aggregation. I've got something sorting by year here at the end. And then the final step is, of course, to sync it to a data sync. So in this case, I have a data set called movie sync. So over here, you can see our data sets here, one of them being movie sync. If I go ahead and click that, we can see, okay, it's going movies output slash, and then the file name. And here I can actually specify, of course, the file name as well, since movie output CSV. Nifty thing is you can debug this. You have to turn on debugging, and what it's going to do is it's going to spin up a Spark cluster, and you give it a time allotment for how long you're planning on using that. Because again, of course, it's going to be charging you while you have this up. So if you enable that, you can actually do data previewing. And in this case, because of my filtering, I'm not sure if I'm going to see any, but basically it'll give you a little preview of kind of what's going to be the output of a specific step. And you can do this at any step in the data flow. Like I said, don't know if this one is going to give us any data because I have some filters on here. A little slow. All right. So if we come back to the pipeline, we can see that's the first step in this demo movies pipeline. And second step I have is to do another data flow. So just real quickly, again, it's going to bring in the same data source. This one is going to just grab us some highly reviewed movies from 1988, with a Rotten Tomato score greater than 75. We'll just see what we get. And it's going to go ahead and clean up some of the column names. So title, I just gave it capital title, genre capital, corrected the spelling of Rotten Tomato, and then I removed some of the columns. So this is a simple select step. Again, there are a number of different steps you can apply here. And they do some of the standard things you might think of. And then, of course, it's going to sync it out to another file, 1988 best reviewed. So if we step back over to the pipeline, we can kind of see, since we have data flow debug enabled, I can actually just run this live. And I'll go ahead and continue with the debug cluster. It's going to take a second. Sometimes it's a little slow. So while we're waiting on that, are there any questions so far? Okay, perfect. Good. Hope I'm not moving too fast. So you can see it's a little slow. In this GUI, you can see it's a web-based GUI. So there's not really an application you download or anything. And because of that, there are some delays in how you interact with it, such as we just saw with the debugging. It can take a while for it to actually, again, kick this over to that Spark cluster. We can see it's running right now, the first step on this demo movies pipeline. So it's processing our average movie ratings. All right, looks like that has succeeded. Took about 28 seconds there. It's really nice. You can actually go in and view the details of each data flow in the run. So as I click the little glasses there, I can see how many rows are calculated. So there were 9,100 rows in that CSV file. You can see how long this stage took 404 milliseconds. And so you can go through, and this way you can kind of debug and see what may be taking longest, what may be slower. Again, how many things are being processed, things like that. Again, good details for debugging. So if I go back to the run, okay, now we can see the highly reviewed 1988 data flow step has succeeded as well. So if we jump back over to the Azure storage, I had the syncing out to the same storage, so we can see two new files: movie output CSV, 1988 best reviewed CSV. So we go ahead and take a look at the movie output CSV. This is the average ratings. We can see it aggregated across the years through 1910 through 2000. The average comedy fantasy rating of those years. Apparently 1943, 1936 were really good. And so close that. And then if we go ahead and take a look at our 1988 best reviewed movies, we will see a familiar title pop up here up top. Aha, Beetlejuice. Interesting. Wonder how that got there. So that's an example of how the data flows kind of work in a pipeline. The other thing that I wanted to go over here was kind of going into how many different things this can tie into and how many different things this can be used with Azure Data Factory. I have this demo pipeline here that kind of gives an example of taking data from different data sources. So in this case, it's taking data from a CSV file and from an open API, and it's going to put those into the same table. And then in the last pieces of this, I have it actually pulling data from a free Pokemon API. It kind of just serves up, general Pokemon information. Picked it because it was I think it's very nifty. It's free. It's very easy to use. I saw it as a good data source. So if we go ahead and look at this pipeline has no data flows. It's just got some copy data steps, lookup step, and a for each step. So, I mean, just this general overview, again, pipelines consist of activities. The activities, there's a number of them. You can even tie into Azure functions. Again, you can utilize individual data bricks. You can do some general things. So as you saw, lookup over there, you could run stored procedures. You can handle setting variables. You can make web requests if you need to. So, I mean, if you needed to ping your own API at a certain step in the process, you could. So again, a number of different types of activities you can use. So in this one, we got a copy data, lookup, and for each. So in the copy data step, we can see some kind of general properties down here. So step name, stuff like that. A source, of course, because we're copying data from the source. So in this case, again, I have a CSV file data set. If we go ahead and take a glance at that, we'll see, okay, so it's pointing again, same blob storage account, right? Data source, input, and then the file. So I have a file loaded up in there. It's a simple file with just some names in it. And then, of course, similar to the data flows, the copy data starts with a source and, of course, sync, right? So I'm going to sync these into this combined table I had alluded to. We're going to merge them in. And the mapping comes up right here. Again, picks it up based on the CSV file. So you can see I got some columns here, 1, 2, 3, and entered by. So I didn't specify in my CSV column names above it. So of course, this is just going to order them. So we got first name, last name, and age is where I'm mapping them to. If we look at the second copy data step, we'll see this one's Copycat Data. So this is its data set for the source is actually a REST API. So if we take a look at that, we can see I'm pinging cat fact ninja /facts. And so this is again, very simple API, just returns random facts about cats. Just thought would be a nifty example. So of course, we're going to ping that. And you get options for things like paging, which I'll show here in a little bit more. It's going to sync them into that same combined table. And we can see what I'm going to do is I'm actually going to map the first fact here over to first name, and I'm going to map the length of that fact to the age column, just for an example. So third step, copy Pokemon data. So again, this is going to ping Pokemon REST source. So if we take a look at that, we'll see this is looking at the Poke API and specifically the Pokemon endpoint in it. It is going to use paging. So the API endpoint is actually paged, which I thought was pretty interesting. So like if I go ahead and pull that up, we can see the raw JSON it's going to return, and it actually gives us a next URL. So it gives us a link to the next page. And so with that, what you can do is, if I look down here, I can specify the absolute URL that's coming from the body as being next. So this tells the Azure Data Factory copy data step to go ahead and go through all of the pages that it can. And so again, we see this is going to sync to a different table, Pokemon table. It's going to map over the results, the name, and the URL, which we'll use in a later step. Here under settings, you can kind of see some of the scaling options you get. So this is available on all of the activities, and you can specify your data integration unit. So if you ever needed to increase this, you can specify your degree of copy parallelism. So again, you can scale this out. And so we'll continue on. Next step after storing those, I'm going to do a lookup step. Lookup step is simply just going to go over the table, and it's just going to look through each row in the table and put those out in the output. And we'll use that in the next step, which is a for each loop. So we're going to loop through all of the entries in that Pokemon table. And if we go into the for each loop, similar to data flows, it's another pipeline basically within there. And so inside that for each loop, for each of these entries, we're going to call copy data again. And what we're going to do is we're going to ping again the Poke API, but we're going to hit the API for that specific Pokemon. We're going to use that URL column we stored first. So again, if we look at the data that this Poke API is going to return on the first step, we see we get a URL for the specific info for each Pokemon. So we're going to have this for each loop go through each of those and store some individual stats about each Pokemon in a separate table. So we can see I'm going to put that in the Pokemon stats table in the sync tab here. And we can see what I'm going to map over. So again, it'll kind of show you the schema based on what API you're pinging. I've already narrowed this down to some simple flat columns. So experience, height, name, weight, stuff like that. And so again, this is going to loop through all of the entries in the first table. So if we go ahead and step back here, step back to the demo pipeline. Again, as I had mentioned, you kind of have some different trigger options. So I had added a schedule trigger. It's kind of an example just to show how you can schedule these. Again, you can start at a specific date, say it's going to recur every 24 hours or every, number of minutes, weeks, days. Currently, I have this one shut down, so this is just running all the time. Just wanted it there as an example. So without further ado, we'll go ahead and trigger this pipeline. And we'll see in the case of not debugging and simply triggering, we get the notification that this pipeline's running. I can watch the pipeline run, so we can see it's already succeeded on the first step, copying the CSV files into the table. So now it's moving into the copying the cat data step. If I go ahead and pull up Azure Storage Explorer, I already have some of these tables pulled up. So I have this sunk into the migrated CSV table. So if I go ahead and take a look at that, we can see some of the info has already been put in here. So we can see, of course, these names, which came from that CSV that it processed. And then we can see, of course, your cat fact. And so again, as I had shown, I'm mapping the cat fact to first name. So we can see, the little cat fact here, and then the length of that cat fact into the age column. So you can see how you can kind of merge, data from a CSV and from an API into one table. Again, you can do that into a number of syncs. In this sense, since data doesn't line up, it's not really structured. Probably a data lake might be better, but I didn't want to really spin up a data lake for this this demo. I didn't want to, get the charges too high or anything on this. So this is still running. We'll go ahead and refresh. Okay, so we can see it started copying Pokemon data. It's looked up that Pokemon data and it's going through each one, pinging the API. We can see this is running in parallel. So we can see it's queued up a number of jobs are in progress, and a number of jobs have succeeded. So this is kind of the power behind this, is when you do a for each, you do these operations over a number of things, it will be able to run and fire these up in parallel in your Spark cluster. So if I go ahead and pull back the Storage Explorer and we look at Pokemon, we'll see this is now populated with a number of different Pokemon. We see their name, we see the URL that it's going to use currently in this other step for the stats. And so as it loops through, this Pokemon stats table will slowly populate. So right now there's only 2 pages because, as you saw, a number of these are still queued in progress. But we can see here a number of the stats that we've mapped over, calling out to those URLs. So, again, base XP, height, ID, name, order. And so in that sense, you can see how, again, this paged API, this paged RESTful API, we're able to ingest data and then further go gather more data about each of the Pokemon that we first ingested and store that in a separate table. A couple other high-level things to cover here. You can see the JSON for any of the activities individually if you want. So, you can see when I go to an activity, I can view the source code for it. So this is ultimately what would get published out as an artifact in your CI/CD pipeline to tie one up. When you're making changes to the pipeline, one thing that happens is you see I get this publish all now, and I get a validate all. And so before I can publish anything, it all has to be valid, otherwise it won't let me publish. When you validate, it's simply going to run through, make sure everything's valid, and then you can go ahead and publish this out. And when you publish this out, this is where, if you had a CI/CD pipeline, this would get pushed out to, maybe your development pipeline, and then you'd publish an artifact that you could later deploy to your test, UAT, production locations. So if I hop over to this manage tab over here, we can see some of the link services. We can see more info about the integration runtimes. If you ever needed to add a new integration runtime or expand one, this is where you can kind of configure and control that. The other configuration you see under manage is, of course, Git configuration. So this is where, if you were going to connect up to a repository to, again, source control the JSON templates, the ARM templates, this is how you can do that. Again, you can connect it to, I got changes. You can connect it to a GitHub repo or a Azure DevOps Git repo. Like I mentioned earlier, it doesn't really work with Bitbucket right now, apparently. You can see some triggers. You can add global parameters that you can reuse in any of the steps. So if we go back to another step, for instance, like this for each, one thing I'm doing here is I'm using, again, the items from this lookup step, the lookup activity, I should say. And I've done that using the expression builder and adding dynamic content. So, I'm saying from this activity, look up Pokemon, give me the output value. That's going to be the items in the for each that we're going to loop over. Likewise, again, you can use those global parameters you just saw. You can use a number of different functions in here to create dynamic parameters for your different steps. You can see, of course, the source code for an individual pipeline. And I think that's about all I wanted to cover. Yeah, so any questions, any comments?
Hey, Johnny, this is Rodolfo.
Hey, how's it going?
Good. A lot of interesting things that you've shown us. I just want to mention that you can also integrate the data factory with the Azure Logic Apps, and you can have the Logic Apps trigger your pipelines. And from there, you have access to other types of triggers, like, for example, FTP triggers or blob triggers. So you can control the pipelines from the logic apps. Just wanted to mention that.
Excellent point. Yeah, good point. Thank you. Yeah, again, it goes hand in hand with the flexibility of Azure Data Factory. It is it has quite a bit out of the box with regards to being an ETL ELT tool. Any other questions? Any other comments?
Hi, Javier here.
Hey, how's it going?
So, good, thanks. I just want to know, so you did mostly everything through the portal from Azure, but so whenever you deploy new changes, you have to go in and make changes directly, or does it offer some sort of version control?
So you do need to make your changes in here. I mean, you could technically modify the JSON directly, but that's kind of where this interface will allow you to validate those JSON changes. And from my understanding, there's no application really to build this out on currently. This is something that you're meant to use this GUI here from adfazure.com. As far as version control goes, it's going to publish, if you tie this up to a Git repo, it's going to publish those JSON factories, the JSON files. And there are options too where you can add in, pull requests. So you can have reviews on different changes being, merged into, a pipeline in Azure DevOps, so to speak. Does that answer your question?
Yes, thank you. Interesting.
No problem.
Thank you.
No problem. Any other questions, comments?
Just want to mention that about what Javi said, that you can potentially copy the files from source control to another data factory and it's going to work. It's like copying and pasting C# code. It still works.
Right.
Okay.
Right. Because that's a good point. It similar to a lot of the ARM templates in Azure in general. So like, again, like app services, you can boil them back down to this JSON file. It's just an ARM template. You could actually deploy, or as Rodolfo would point out, you could copy an app service using that, including pieces of its configuration and whatnot. So that's an excellent point. Any other questions, comments? Well, with that, thank you everyone for your time. I hope this was informative or helpful. Because there's a kind of high level quick overview of Azure Data Factory. But again, thank you all for your time and hope you all have a good day.
Thank you, Johnny. Nice
Thanks, Johnny.
presentation.